bootcamp kind of session. So what we are going to learn today, so it is like you will find the answer for these questions. Questions like what is a container, what made container possible, what is Docker, what is Kubernetes, how container technology market trend, and what is container administrator will do. When I say container administrator, basically it is a Kubernetes administrator, Docker administrator. Okay, before actually we get into what container technology is it is, before that just we see what is this container which is used in the logistic industry or transport industry. Okay, so if you see a container, okay, in a logistic or transport industry, okay, it has a point A to point B, maybe both the case it might be a warehouse or a distribution center. In a container, usually people used to stuff materials. Okay, once it's sealed, it will be moved from between the continents or between the countries. Okay, during this transportation, you can see this container can easily fit into a truck, a lorry, or even it can be transported via train or rail system, and can mostly in the ships. Okay, and it will reach a final destination. So the role which this container plays here in this logistic industry is making the goods movement easily, seamlessly, irrespective of the location or type of the transport. It helps makes the goods move freely and seamlessly. Plus, it helps containers to tracking also. Okay, right now this good in which country or which port, so you can track that also. That is the role which container does in logistic industry. Okay, whether this container has any relationship with our container technology, yes. In the business perspective, the purpose which solves in logistic industry, similarly the container technology in IT industry solve the purpose of moving the code from one environment to another environment. Example, development to test, moving from physical servers to virtual machines, or virtual machines to clouds. Same way to the application tested in the Linux box can be, same application can be easily put in the Windows environment. Okay, so yet like that container, the container technology also helps to move the application, port the application easily. Okay, so theoretically, or again I won't say theoretically, in layman level, what is a container? Is a method of packaging an application, that is code plus dependencies. What is a package will contain? The package will contain code and dependencies. What is code? What is dependency? We'll see it in the coming slide. And another important purpose of container is it can run independently. As I said, once a container has been built, okay, and it is able to run in a Linux box, it will run in a Windows box also. A container which is tested in the virtual machine, very much it will run in the cloud, whether it is a Google Cloud or AWS or Azure. Okay, how it is working, we'll discuss in the coming slide. One important thing actually is this container technology is new to IT industry, because majority of us last 2 years or hardly 3 years we are talking about it, and recently everyone started talking because two things. One is a Kubernetes, a Docker container, and other one is a cloud. These are the top two topics of the town. Okay, so this container technology, is it something came new into IT industry or in the technology landscape? Actually, it is not. Okay, it may not be the technology container platform what we have right now. It may not be the same shape or same which people, a similar container which we talked about 1947, 1979 in Unix world. Okay, most of the Unix administrator might know there is a option called chroot. Okay, with troubleshooting or when you edit some configuration file, the chroot will come into play. It is like a container which is available from 1979. Okay, so from there the container, okay, basically it's what that chroot will do. You can do certain operation that won't affect the other environment outside that environment. Okay, that is the basically purpose of the chroot. From there it started evolved. Okay, various requirements, various new things added. Okay, so it started evolving and it has reached the place where we are currently seeing current container technology. But during this evaluation period, one major step happened on 2013. That is done by a company called Cloud, which is now Docker inclined. Okay, during this evaluation, okay, all different type of containers. Okay, the set of process will run. It won't affect other process outside that group of process. Same time, other process cannot intervene or affect this particular process which is running inside this container. Okay, but the major change 2013, which the Cloud Docker inclined brought in, is something called Docker image. Okay, so what the purpose of Docker image we're going to discuss in detail. Okay, but in simple, or at this point, what I can say is, once the image is ready, it is like you have a image which you can run it in any environment. Okay, so image, what is the image? We'll discuss that. Okay, so actually we really get into container. Okay, is it a container new to system administrator or new to infrastructure guy or a new to Linux guy? Mostly sometimes we can see a system administrator talks, okay, container something for a developer. Okay, actually the container what we have, it is made possible because of Linux kernel. Okay, the Linux kernel has two important features. One is C, another one is namespace. Okay, as of now, assume a process, a single process. Okay, the Linux kernel has a feature called C group. So this C group, what it will ensure is a single process, how much CPU it can use, you can restrict using the C group. Say if you say, well, just an example I'm saying, it can use only 10% of the CPU to configure in C via C group, it will ensure that particular process only uses 10% of the CPU. Okay, same way there is a, so this is what C group will do, it will limit how much S process can use. The second feature is namespace. Namespace, what it will do for a process, it will limit what the process can see. Means, say assume that in a Linux operating system you have 100 process. Okay, assume that, logically you assume that there is a process called 90. Okay, so if you want to see this process should be visible, this process can see only process 91 and 92. You can configure a namespace, you can, just an example I'm giving. Okay, you can through namespace you can encapsulate this process 90 so that it can see only process 91, 92. So it will assume only two processes running in the system. Okay, so these two Linux feature, which is C group, which limits how much resource a process can use, and the namespace, which will limit what a process can see. These two are the primary core components which given a path for current container technology. Okay, plus in this diagram I added an image. Okay, we'll see what in the coming slides. So C group, namespace plus image will give you the, which given the container platform what we have right now. So what is the advantage of having containers? Okay, because we have already physical machines, virtual machines, and now we have a cloud options also. Okay, in spite of all these infrastructures available, what is the advantage we are going to get it from containers? Okay, the first one will be build once and run anywhere. Like in the previous slides I told, okay, you develop application in a Windows, test it, and it is working fine, means that will become a container image or container. Okay, just you copy that image into Linux machine, it will work. Okay, only prerequisite that Linux machine should have a container engine. Okay, we'll come to those things in later. Okay, so likewise, application which is working fine in a container platform in Linux can easily work in a Mac OS as long as it has a container platform software. Okay, same thing, application which is tested in a physical machine working fine along with a container engine. Okay, then it will work for sure in a VM which has a container engine. It can work in a cloud. And when I say cloud, it is on-premises cloud and public cloud also. Only thing is, all you need, all this environment is you need a that container engine. Container engine is nothing but your Docker software, okay, or any other container software. Second important thing is TTM deployment, TTM, time to market. Okay, so what is time to market? Say for example, if you go to 20, 30 years back, assume that I have a organization, I want to host my website. What I need a physical server. I need to buy it, rack and stack it, install operating system, then install web server, say HTTP or Apache or a WebSphere. Okay, then I need to configure all this. Then I need to deploy my code so that my website will be available. So what it will take? It will take from days. For sure, it will take a week at least because you have to procure a server. So that is the duration. What next we came, that is a virtual machine. So if you want to bring any virtual application, a virtual machine, yes, your rack and stack physical server won't in picture because it's already available. But so you have to create a VM, you have to install operating system, then you want to configure your software, then you need to deploy a code. Okay, so it is almost a physical server. Only thing is you that physical effort of racking and stacking on those server that has been eliminated. So in this case also, it will take few hours to some cases days. Okay, what in case of container? Okay, so in container it will take few minutes to hours only. How? Say for example, because already underlying hardware operating system which is already available. When you want to port your application, just you need to create an image and you need to deploy your application. What is that creating image? So you need to tell, okay, I need CentOS, I need JBoss, and then I need this configuration, then my code. Okay, if you bundle everything, that will become an image. So when you do this first time, it will, because all your images are CentOS or Wildfly are already available in the Docker app or in your local register, which is already available. Yes, you need to pull those images, bundle it, run it. Maybe first time you might encounter some errors. Okay, so bringing an application in a container environment for the first time, it will be few minutes to hours. For example, same application tested successfully in a test environment. How much time it will take if we move to production? It will going to take only few minutes, because in container this same software, same image, this I'm going to copy from my test environment to production environment. So I'm going to just starting, just like everything is ready, you just power it on, kind of stuff. What is that? We will discuss that also in detail in coming slides. The next one is code reuse. Maybe the example which I discussed earlier, but also part of it, like the code when we created and tested in a production that can be used in a test that can be used in a production also. Say for example, if you are working for a larger corporation which is presence across the globe. Okay, there is application or software which is developed for North America region. Okay, once it's created, the same application that they want to use it in a Europe or Asia, they can get this image and they can start using it in a few seconds. Okay, so the first time at least it will take few hours. With the same applications we are going to use, it will less time. So where it is TTMs and code reuses are coming into picture. So where you will keep this image, that is a registry. Okay, we'll talk about registry also in coming slides. Startup time, it is going to take very less time, milliseconds to few minutes. If you take a physical server, if you from the cold boot, okay, it will take almost 10 minutes, around 10 minutes. Okay, if you take a VMs, it will take few minutes. Whereas in a container, it will take milliseconds. Rare cases, it will take few seconds, so few minutes. Sorry, few seconds. So advantage of having container compared to other platform: build once, run anywhere, time to market is fast, code reuse, startup time. This is the another important topic which generally discussed between in the IT industry, maybe between the developers or the system administrator or middleware administrator, or maybe, because we usually compare what is the difference between containers and virtualization. Okay, basically in layman level, virtualization is nothing but virtualizing the hardware. Container is nothing but virtualizing the operating system. Okay, so you can see this diagram, the first diagram, which is for virtual machine. Okay, you can see the bottom one is the infrastructure where your server, storage, network devices, the hypervisor. Okay, so on hypervisor you have a VMs. Okay, say for example, application 1 want to write something on a disk. Okay, so say for a user has given some input in the UI, so which is nothing but some information needs to be updated in the database. Okay, so that information will be given to application to that relevant software, say Oracle software, then it will be given to guest OS. Okay, maybe this case it may be your Linux server or Red Hat server, RHL 7, 6 or CentOS, or your guest OS maybe your SUSE Linux also. Then it will that instruction will come to hypervisor. In case of VMware, it is EXSI host. Okay, that is also another kind of operating system, but technically it is hypervisor. From guest OS, the instruction will give to hypervisor. From hypervisor, it will reach the actual hardware. Okay, so these are the layers involved when you do any operation or any action on an application which is running on VM. Okay, so you have these many layers. Okay, whereas if we in container, okay, the same infrastructure, you need servers, physical servers for sure, you need storage, you need network, then only it is going to connect. On top of it, you need operating system. This operating system, in case of a Docker, you are going to use Docker. Your operating system can be Linux, Mac OS, and Windows, but traditionally or typically it would be any Linux operating system. Preferably it will be Red Hat or SUSE Linux. Okay, on top of it you will have a Docker engine. This Docker engine is nothing but your container engine, which is nothing but your Docker software. Okay, if you install a Docker software, that will behave as a container engine. Okay, so on top of it you have binaries and libraries and applications. Okay, what is this binaries and libraries? One term you can think about your drivers. What driver you usually do? You have a hardware, you have a software, any instruction need to talk to printer means you need a printer driver. If you want any instruction give to any of the say network admins, you need a network driver. As of now is the first session, you can assume that these are the libraries and binary means it's a kind of driver, means whatever instruction this application gives, these binaries and libraries will convert that instruction and tell it to compute engine. Okay, some cases it can directly talk to operating system also. That is the role where this binary and libraries will do. Okay, in VM case also we have binaries and libraries are involved, but still it will communicate via guest OS, whereas in container it can directly communicate to operating system. That is the main advantage these libraries and binaries are playing a role. We'll discuss that also later. So this case, what will happen when you create a container, when you do something with the management activity with your container, your container engine will come into picture. When actual application works, okay, as an example which we talked about earlier, we have a database which is running on app1 in container diagram. Okay, assume that is a database. Just I'm taking an example of database. Okay, so assume there's something you're giving a write instruction and you're saying save. Okay, so app will contact binary and libraries, and the binary and libraries receive that instruction. It will tell to base operating system, host operating system, what needs to be done. Then corresponding hard disk or server will be involved. The physical hardware will be involved. That action will be performed. Okay, so that is why the two things here, the operating system got virtualized, means app 1 I can have operating system CentOS, app 2 I can have operating system of CentOS Ubuntu, app 3 can be my Windows operating system. So on a base operating system, we say example RHL. On top of it, app 1 will assume I'm running on CentOS, app 2 will assume that it is running on some Ubuntu, and app 3 will assume it is running his application on the Windows. Okay, that is one difference. And second difference, that is why we call it as a virtualizing the operating system. And technical difference and performance wise, from application, instruction goes to binaries and libraries on real runtime, and directly instruction given to base operating system, then a hardware will be the actual action will be performed on those physical hardware. Okay. So what is Docker? Docker launched in 2013. The second slide, I think the third slide, whatever we have seen it, it is the Docker container kind of a technology or a requirement which is started from 1979 onwards. At 2013, Docker brought in a concept called Docker image. That's where the current container technology whatever we saw, which started evolving from there. So Docker started in 2013. Docker container is a software that package up code and all dependencies. Okay, and again I'll come what is code, what is dependency. So what we are achieving by packing up this code and dependency. So what we are achieving, this application run quickly, reliably, run from one computing environment to another computing. Why I need to package this? Packaging of what? Code and dependency. By doing this, what I'm achieving? I am achieving the two things. One is I can run my application quickly and I can move my application from one computing environment to another computing environment. What I mean by one computing environment to another computing environment, if you take of a physical infrastructure, it can be as data, a physical machine, virtual machine, cloud, anything it will run. In case of operating system, it will run on any Linux operating system as well as Windows operating system. Okay. So what is code and dependency? In general terms, the terms we use code, which is code which is created by the developer. Runtime. Runtime is nothing but you can see here Docker, the Docker software which runs whenever we issue a command, it creates the container. It starts the container. It stops the container. Okay, and if you want to, so these are the Docker software will do. So that runtime. Okay, then system tools. System tools libraries, nothing but you can think about operating system. Okay, so when I say I want my, say assume that I'm packaging a web application. I want to host a website. Okay, so to host a website, what are the things I need to package? What are my website code? Docker engine I should have, okay, and related some drivers kind of binaries which required to communicate to Docker. That runtime I need to have. System tools and system libraries, nothing but I want this application to be run in RHL operating system, CentOS 7 operating system, Ubuntu operating system. Okay, so these system tools and system libraries is a combination of that. Okay, and I can give you one more information. Say for example, typically if you download any CentOS, okay, operating system, it will come around 3 to 4 GB. If you install it, even if you install as a minimal installation, okay, if you install in a VM or a physical machine, it will consume a disk space of close to 800 MB to 2 GB, the minimal installation. Whereas the same CentOS image, which is available in the Docker hub or Docker registry, where these are got from Red Hat and other vendors, and Docker has kept it. Okay, the same CentOS operating system, when it's come to Docker or when it comes for container technology, it will be between 200 to 300 MB. What it means is, so CentOS will have the necessary files or necessary commands or necessary drivers which is required for only container environment. Okay, it won't have any other files or any other additional software. Okay, say for example, RHL or CentOS can have a LVM. Okay, so the original software will have those software also. Whereas when it comes into operating, container image, same CentOS 7, who need those files needs to be present here. Okay, so that is why it will be in very less size. Okay, so coming back to this system tools and libraries, you can think it is an operating system settings. Okay, first I have CentOS 7, then I have a web server, say JBoss or WebSphere. Okay, I will have that image. On top of it, I will have my application code. What is the setting means? I will say my application needs to run on port 80. My application needs to run on port 8080. Like these kind of settings. Okay, so those also will be part of this packaging. Okay, so packaging technically what we'll say, it is a package of codes and dependency. If you see what is the code and dependency, it means your code which application team has written, runtime, the driver which part of Docker which needs to communicate with the Docker engine if required. System tools and libraries, nothing but a limited or miniature form of your operating system. Then settings, which is nothing but like which port your application needs to run on. So Docker generally it has two versions or two edition. One is enterprise edition and community edition. Okay, so like any other software. Okay, so community edition, because it is started from the free open source or freeware community, so always Docker needs to contribute or maintain a community edition for all its version. Okay, so where you can get the software maybe with the limited features. Only thing is you need to install, manage yourself. Anything comes, maybe you can contact community edition, but you cannot contact or claim Docker as for official for any issues you face. Whereas if you use enterprise edition, yes, Docker is there to support you in case of any issues, and you will receive the new features and support then and there. Okay, so that is the thing, like it goes for any products available in today's market. Okay, community edition and enterprise edition. Docker architecture, to be honest, this needs to be discussed maybe 2 to 3 hours. Okay, but we'll try to cover it in this slide in a few minutes. Okay, but don't worry, in coming sessions these things we are going to really discuss in very detail. Okay, so Docker architecture, before we'll see how the Docker architecture, we'll see what are the major components: Docker daemon, Docker D, Docker client, Docker registry, Docker images, Docker container. What is Docker daemon? Which is like a master of your master daemon, which controls the rest of all the components in the Docker engine or Docker software. Okay, like creating image, containers, networks, volumes. Okay, Docker client, it is a Docker client. Maybe you can think it is something like a command. Okay, using that command you can interact with the Docker daemon. Okay, what I mean by interacting a Docker daemon, by Docker command you can tell your Docker daemon, start this container, stop this container, create this image with unnecessary inputs. Okay, so Docker client is nothing but, as of now, you can take a Docker command which you can interact with the master daemon. Docker registry, which is very, very important, but as of now you can see things like that is a place or where you can store your images. Okay, so what it means, say for example, as I said, first there is application required for HR department which needs to be run on CentOS, JBoss, then that HR software, whatever code, application code, application team has developed, all are packed, okay, and stored. And then there are some services running on it. Okay, similar way, finance department. Okay, but they want in Ubuntu, and they want instead of JBoss, they want WebSphere. Okay, and they run their code. Okay, that one more image created, you can keep it in your registry. And our finance was using it. Assume that tomorrow some other team, say for example a logistic team or some other team, want these two combination. So instead of they can create from the scratch, they can take it from the registry and they can start using it. Okay, so that is a registry which plays important role or a major role in the container platform or technology. But as of now, you can keep it like this. It is where you can keep and store all your images. Okay, what is Docker images? Okay, Docker is a read-only template with instruction for creating a Docker container. Means assume that it is like a script. Okay, what usually the Linux guys will know, right? You inside a script you say we'll create a directory, copy a file from this folder. Okay, then run this command. Okay, if you type these 3 commands and if you run this script, what it will do? It will do those 3 steps. Similarly, okay, there is a Docker file they use it, call it. As of now, you can think like a template. The template will have an instruction for creating a Docker container. Means what? Include CentOS base image. Include JBoss JBoss software image. This is the application code. To start this application, run this command. These are the example of what those instructions. Okay. So you'll have an instruction, then you'll have the components, whatever I mentioned. OS, CentOS, software, maybe HTTPD or Apache, and your code, which is created by the development team. Then configuration, as I said, this application needs to be run a port number 80 or 8080. So that configuration and how to start the service. Say for example, systemctl start HTTPD. Okay, these are the things which will Docker image will contain. So what is Docker container? Is a runnable instance of an image. You have an image, okay, but still is whatever inside that code you cannot access it. Okay, so container is when that image became a runtime. When that service, say for example, maybe it's a wrong. Okay, you can take it like this. Docker image is like your DVD. DVD means like you have empty DVD. Creating images and you writing some data on it, say some movie you're copying in it. Okay, Docker container is nothing but a DVD player. You just place your DVD and play it. You can watch your movie. Okay, like that. Docker the image is nothing but DVD, and a container you can take it as a DVD player, so that whatever you can access your application like viewing the movie. Okay. So container you can start, move a container from one environment to another environment, or those steps. So all Docker engine will involve do these operations. Okay, in a Docker container, because so far whatever we spoke, okay, maybe something some one doubt will come into your mind, right? So since we already packed and it is read only, so you cannot have any anything stored on this container. Yes, that is also possible. Like you can attach external storage. So image will be one time written. Okay, you can attach a storage while it's run, that you need to mention in your instruction. Okay, take this piece of the storage. Through container application, through your application which is running in the container, you can write information and you can access that information many times, or you can modify it also. It's a bit complicated. In the coming session we'll talk about it. As of now, container, it is like, just think image is your DVD and a container is like your DVD player, which helps to see or view what is inside the image or the software. So if you have any questions, so raise your hand. Maybe I can take your questions. Maybe we'll pass for 1 or 2 minutes for questions if you have anything. Okay, meantime, let me have some water. Okay, let's move on. So what are the components we discussed in the previous slide? Okay, so it is like a kind of a professional description. Okay, the client, which is the Docker command. Using the Docker command, you can build image, you can pull image from a registry, or you can run a container. Okay, that's your Docker command will do. The Docker host is the where the main software or Docker engine is installed. Okay, we're using the main daemon. Images can be interacted or images can be created. Okay, so images can be pulled from registry, or it can be created based on the instruction or a Docker file. Once it's available as an image, you can spin your containers. Registry where you see store all your images. Typically, how the life cycle of the Docker. Okay, so what I mean life cycle, say for example, if you take any virtual machine, creating a virtual machine, one stage, then installing a software, including your operating system, other softwares, then deploy your applications, working fine. Once a requirement for that application is over, shut down or delete that VM. That is the life cycle of a VM. Okay, when it comes to container, typically you need a Docker file. See, argumentally you don't need a Docker file, but generally you need a Docker file, because no, if you want to reuse it, you can, instead of specifying the instruction in the Docker file, you can type it and you can do it. But if you want to same step again, okay, you need to manually type. So always do through Docker file. Okay, so first you need to create a Docker file. Using the Docker file, image will be created. From the image, it will become a container. Means something like you power it on, your application came live. Okay, people have started using it. That is a run container. It doesn't use, so you manage it. When you say manage it, some troubleshooting or maintenance activity. So the fourth step is manage. Once the requirement for that application is ends, that will become end of life for that container. Just remove it. Some case what will happen, it is run for a few months, then you identified a bug or you need more enhancement, then go back, modify the Docker file with a new enhancement, or add your updated code, again create a new image, run as a container, manage it, kill it, or again go into the loop. Okay, good so far. Portability between operating system, between the hardware platforms, between clouds, okay, looks promising, but something is missing. Whether this, so far whatever we discussed, this container technology or a container is good for production or good for enterprise? No, because we didn't talk about high availability, we didn't talk about scalability. And say one container, okay, fine. Okay, what will happen is the companies are having a 300, 400 applications. Even I heard of a company has 800 applications. Okay, then it is a central management will come into picture, which is not addressed so far. Whatever the Docker or containers technology we discussed so far. So this can be overcome by software called or another tool called Kubernetes. It shouldn't be a tool, it is a software. Okay, so what is Kubernetes? It is a container centric management environment. We'll see what it is. Okay, or generally if you want a container can be managed in a better way using Kubernetes. Okay, who has created this? Originally this Kubernetes software was created by or written by Google team, then it is donated to the open source community. Okay, using Kubernetes software, okay, what else we can do? You can scale your container, load balancing, logging, monitoring, and other management features of centralized application management. Okay, the management is missing here. Okay, okay. Before I proceed, there is a question. Usually, people mind will have, okay, whether I need to have a Docker software or Kubernetes software. Okay, whether I need a container engine or a Kubernetes engine. Okay, so these are the two different tools which needs to work together to achieve this features: high availability, scalability, and centralized administration. Okay, so what it means is using Docker. Say in this case, okay, using Docker, you can create a containers whatever we discussed so far. Okay, say assume that you created a container, your application running on one container. What will happen? For some reason that container got crashed, your application become unavailable. So you need high availability, redundancy. So same application needs to be run on two containers. Okay, that is one example. Okay, sometimes when you same application running on two instances or two multiple more than one place, you can use it as a load balancing as well as for redundancy purpose. Okay, one example. Another example, container which is given by Docker. Okay, now you have one container. 10 people started using it. Tomorrow it became say it is only US people are using 100 users. Then they added Europe. not 100 user became 200 200 users, then whatever because initially the resources are calculated for 100 users, then you can spin up one more container instantly, okay, with the same capacity, which will become a load balancer to accommodate a new load. Okay, so from one application in one container, okay, in Kubernetes world we'll call it as a pod. Okay, as of now I'll park that because we will, for the first session we'll just assume as a container. So one application for 6 months running in one running inside a container. Now more users, you want to scale, you want to more containers so that it can accommodate more users. In Kubernetes, don't do anything, just say replica for 1 to 2. So instantly the new container will be pop up in few milliseconds, okay, and the load can be shared. Okay, so this feature, it is coming from Kubernetes. Okay, so there's high availability, scaling, logging, but when you have multiple applications for troubleshooting or tracing something, you need more loggings, monitoring to check. See, actually, as of now, the monitoring is not that efficient in a container, not only Kubernetes, in container platform as it's evolved. Okay, other management activity. Okay, so again, I want to emphasize, you need a Docker software to create a container. You need a Kubernetes software to make the container in a cluster environment so that it can be highly available, scalable, and other centralized management software. Okay, so for Kubernetes, so you need only Kubernetes. No, Docker itself has a Docker spam, and there are other orchestration tool or clustering for container solutions are available. Widely or mostly used is Kubernetes, because another main reason is in cloud world. If you take Google Cloud, it has a Kubernetes engine. So in a cloud world also, Kubernetes are widely used. So that is the combination usually people will do: containers from the Docker and cluster management, which is technical word orchestration, which has come from Kubernetes. Same thing, whatever we discussed so far. So what is the advantage of having Kubernetes? Supports both stateful and stateless kind of applications. Auto scaling, it is running in one container. Without disturbing first container, you can spin off the second container. It will start behaving as a redundancy or load balancing. So auto scaling, a resource limit. Okay, you can ensure, okay, when the new container starts, it can use only this many CPU or the memory. Those things you can limit, and you can modify that also. Extendability, you can you have your cluster environment, okay, which is in production. You can for test environment, you have another environment of production that can be integrated or moves containers in between. Portability, a application which is running on the physical machine, means a container which is you tested or it is working so far in a physical machine or virtual machine. You can move it in any cloud, your on-premises cloud or public cloud. When I say public cloud, it can, whether it may be GCP, Azure, or AWS. Okay, so just pass our discussion on a technical front for some now. Okay, let's see how this container technology, what people in the industry talks about, or where this container technology stands inside the industry. The survey has been taken, it's quite older one. Okay, so if you take 2020 right now where we are, which is around 2 billion in the, as per this survey, which is around, it will become a 4 billion in next 2 years. What it means, it is going to be double, almost double. Okay, that is the one thing. Based on these surveys taken from 184 vendors, starting from Docker to all other local vendors on this landscape. Okay, this is the money value projections which container market has. Okay, from 2 billion to 4 billion, which is almost double in 2 years. Adoption level. Actually, it is not matured in the industry, not in the technical perspective I'm talking about. In the usage level, it has not really climbed up to the ladder, whereas it is catching up fast. Okay, if you see the survey, I think they have taken, I think 426 companies. Okay, out of it, you can see the top. If you take top 3 or top 2, close to 40% or 50% people, they started using it. It's around 19%. Other 30%, one or other way, they have started using it, that they're doing a POC. Okay, or thinking about using it. Okay, but still, other 50% of the companies or respondents says that they don't have a view, or they didn't thought of using it. Okay, but so when I said right, this 50% of people, they say responded saying we have not thought about it, or we didn't thinking of using container. Okay, it is same thing. These kind of reluctant or discussions which happened to say when you say early 2000, when people completely on physical machine, when virtualization VM comes to few people, they take that as opportunities and started using VMs. So most of the people initially, okay, they became reluctant that you cannot get a performance like in a physical machine. You will have this advantage, you will have security issues, like a lot of reluctant in adapting the virtual machines. Okay, but eventually what happened till now, it is if you take any data center, at least minimum 80% will be a virtualized. Okay, that is what the 15-20 years which we saw in the IT infrastructure. Same way, okay, as I said in a previous slide, Docker image, whatever, it came 2013, but if you talk of 2 to 3 years, okay, 2 to 3 years, but still people are saying, okay, no, VM you will get a better performance, the containers you have this you don't have this feature, you don't have that particular feature. These kind of talks people have in their mind because of one reason, they're reluctant to adapt, and second reason, still the software itself it is coming up, evolving. So it maybe down the line a couple of years, it will be a more mature product than what we have right now. Okay, but the fact is how physical machines were almost thrown by VMs. In coming decade is going to happen with the container, because it is a transformation of landscape or infrastructure how the industry seems. Okay. Okay, so what container administrator will do? Okay, or when you attend this course, what typically you will learn and what typically you will perform in your job environment, managing the container platform ecosystem. It means installing container softwares, Kubernetes softwares, okay, and configure it, upgrade, patching, monitoring. Okay, primarily your times will be spent on these areas. Okay, typically like for any system administrator, how we manage servers and operating systems. Okay, and cluster capacity management, which is very important, because have how much resource has been utilized from your base OS, because sometimes what will happen, right, you are onboard more application, then you end up in application getting crashed because you don't have a sufficient resources and that stuff. On preventing and managing underlying host, sometimes it may not be a part of a container administrator, it might go to a hardware engineer or system administrator or OS team which manage that underlying hardware. Okay, but this is a situation right now, but what I predict maybe in future, like how Windows administrator become a VM administrator. Okay, this thing can happen. Okay, POCs and migration of application to container platforms, because this is where now most of the companies are into. Okay, they're Docker, they even Cisco has some container, IBM has some containers. So people have started doing POCs of their application in various container platform, and they're trying to find out which is the best suit them. Okay, same time they explore the various container solutions which is given by the cloud providers also. So these are the main areas which the container administrators are currently into. Advocate containerization technology and adoption. Like I said, say if I'm a container administrator, if application teams approaches, okay, I can say that since they might not have a confident, or they might not have a full information about technology, as a container administrator, you need to give more insight about the containers and options available so that you can gain their confidence and they can come forward into containers environment. So messages, groom yourself on the Docker and Kubernetes technologies, become an administrator. Just to be honest, okay, like cloud, this Kubernetes Docker skill is also very hot in the industry, which is add more value in your resume. I almost done with my content. So any, I think we're close to our time also. Okay, so anyone has any questions? I think someone had some questions.
Yeah, we have Subbu. We have some questions to take up from Subbu. Subbu, I'm going to unmute you. Please go ahead and ask your questions. Yeah.
Thank you.
Hi, Subbu.
Am I audible?
Yep, go ahead.
Thank you. Right. The question I had was around auto scaling aspect of Kubernetes. Right? I'm trying to understand, how easy and how automatic is the whole process, right? And how complex it is for me to create a scalability element for a particular container.
Okay, I can tell it in two steps. One is as easy as a command with 4 or 5 letters. Okay. A second thing is how much time it will take to auto scale in seconds. Maybe your infrastructure is not configured in a better way, maybe a few minutes.
So just throwing a scenario, right? Say, for example, I have an application and I'm sizing the application to utilize this much of database space, right? And then I'm realizing that the usage of my application is automatically increasing, or the database is running over. Will a code be written in a way where the database will be auto-scaled automatically, right? Understanding that yes, there is more space needed, or because you said that we have the concept of limiting our configuration into a container, and that it will only use this much space. Will it limit itself and say it will not auto-scale?
Okay. I'll take different example maybe, but still that will answer your question. Okay, say assume that I have a web instance, okay, which is running on CentOS web server, the Apache web server, okay, and my code. Okay, for one container, actually in Kubernetes world we should talk as a pod, but still with the limitation of our session, I'll say container. Okay, so I said for this CentOS Apache, for my code I allocated 1 CPU, 2 GB RAM, and it has started running. Okay, now I'm talking about auto scale because my load has increased. I need to bring one more instance, typical one more container. So for my load balance, as I said, just a command replica. I'll say 2. The command will complete in few minutes. Okay, so what will happen in the background using the same image? You already in the image you configured, right? Your JBoss, CentOS, Apache. This is your code, and 2 CPU, 1 CPU, 2 GB RAM, all will be taken from your image. Parallelly, the second instance starts in a few seconds.
Sounds good. Okay. Thanks, Frank.
Yep. Thanks, Muthu.
Thank you, Subbu, for the question. And we have a couple of other questions. Arul, please go ahead and ask your question. I'm going to unmute you.
Hi, this is Arul. Thanks for unmuting. Okay. Hi, Francis. Like the question I have is like, is that a Docker is the only solution for my containerizing of my application, and also like for orchestrating the container? Is that a Kubernetes is the only thing? How about the Docker cluster thing? I just want to understand what are other tools over there and how best is Kubernetes? How everyone is just opting Kubernetes for the containerization, or is that other tools are also being used there?
Okay, so answer your first question. Okay, for container engine, Docker is not only the solution. You have many more options. For orchestration or clustering, Kubernetes is not the only software available in the market. There are other softwares also available. Since the time constraint, I didn't talk about those things. Okay, so to answer your first question. Second thing, why people going for Kubernetes or Docker, but again Kubernetes? Okay, because of one reason, the main driving factor, right? It is came from Google. Okay, so just an example how a Google product will be. Okay, and second thing, yes, still POCs are happening, and that's all fine. Okay, but people are near future. They talks about cloud or on-premises cloud or public cloud, where Kubernetes is very strong. So that makes Kubernetes as an ideal candidate when people talk about this technologies. I answered your question?
Yes. Yeah. That's. And other thing is like, is that like all the application can be containerized? Most of the examples whatever I could see is Apache or any web servers is mostly they're talking about. If you think of a very big enterprise applications, more of like SAP or like any database related applications, will that also will come into the containerized application stack later, or how is the things moving on?
Okay, I answer it again in a two-step. It is like when people say virtual machine, people there are people say that only certain application can run only in the physical machine. Likewise, theoretically, you can run any application on the container. Okay, theoretically. Okay, but when you talk practically, what means now? Say for example, as of now, the container technology evolved or the maturity of the container platform. Okay, you can easily host in a web applications. Okay, in the current container. Say assume that you cannot host. Technically, you can host a database, but you cannot host a heavy IOPS database in the container. Okay, because of the current structure and infrastructure or the maturity level of the thing. Okay, got it?
Got it. So IOPS related applications maybe.
No, as of now, today or at this point, you can say that it is not a suitable candidate for a containerized. But technically, still you can have a database in a container. But in enterprise level, that won't solve your problem. You'll end up in latencies and crashing.
Okay, I'm good. Thanks for it.
Thank you, Arun. We are running short of time, and we have a couple of other participants. Vijayalakshmi, please go ahead and ask your question.
Hi, thanks for the session. I would like to know about the certification that is related to Kubernetes and Docker, like how you said, what about the course and how much the cost is, and what are the competitors of this product?
Okay, so course content, those stuff, I think Vasant will cover it after once I finish. Okay, about a certification, Docker. It is like aptitude kind of exam, which is you can have it in online or any promoting center. Whereas in Kubernetes, it is like you will have to prove. They will give some steps which you need to perform, and you need to perform those tasks online during that exam, and you need to clear it. Over attended RHL Red Hat exams, it is like a similar one. Okay. And our course content, okay, usually maybe people who knows about us, okay, mostly our content is not about certification. Our content is mainly about how you can face interview, how you confident you will be in work environment as long as you got a job in that particular technology. Okay, so our focus is acing an interview and giving you confidence in the real-time work environment. Okay, but doesn't mean that we won't cover about the certification perspective. Somewhere we can, some sort we can help you on it. But our main focus is preparing your real-time candidates and ready to go to job.
Okay, thank you.
Thank you. Ram, please go ahead and ask your question. I'm going to unmute you.
Hello, hi Francis. Hope you are doing good. Thanks for the session. Ram Prasad here. So just want to know, the Docker container software and this Kubernetes client, it has to install on all the target servers, or it's not required?
Say for
the
example,
agent, I mean. Yeah.
Okay, assume that you have 5 servers.
Okay.
Okay, the server 1, you should have a Kubernetes engine, sorry, Docker engine and Kubernetes engine. When I say engine, the actual software or master software. Other 4 nodes, okay, is going to be have your workloads, your containers. Okay, those things, the agent of the Docker engine, agent of the Kubernetes engine, only those can be installed. So those agents will talk to these masters. So it will work like a client server architecture.
Okay, okay. So it's mandatory to install those 2 agents on the target servers, target nodes.
So assume that if you talk in a master node perspective, the master should have your Docker software and Kubernetes software, complete software or a complete engine, whereas the nodes can only contain your Docker engine and Kubernetes agent.
Okay, okay. Yeah, Francis, got it. Thanks for that. And this our course will be online, or only it's a classroom session?
No, as of now, it will be online.
Okay, okay. Okay, Francis. Thank you so much.
Thanks, Rob. Vasant, over to you.
Thank you. Thank you for the wonderful session, Francis. It's really good to know about the basics of containers and Kubernetes. Yeah, to talk about the course we are conducting, we are planning to take the 24 hours of total hours for this both Docker and Kubernetes. This is going to be the online live instructor class training. So we are planning 4 days a week. So starting from it will be mostly on weekdays, every day 2 hours, and planning to start on by next week Wednesday, that is August 5th Wednesday, the same time 7:30 to 9:30 a.m. IST, and this will be going to be flexible based on the participants and attendees. And I'll also want to tell you who are the participants going to attend this training. So to becoming a Kubernetes administrator or the container administrator, it is a highly desirable goal for those seeking the fast track in their careers, especially in the DevOps industry. So with a number of DevOps opportunities in the market, it's very rising every day, and any system admins or the cloud engineers, if you are a software developer or an architect, or if you are a student, you are very much eligible to take up this training. Okay. And what does this training include? So what are the features we are going to cover? So we'll be providing you customized study material. So those who already know about RWX, they'll be aware of us. Like we'll be giving the very short and made easy custom study material that will be very helpful for to understand anyone, even without IT background. Also, you'll be able to understand our study material. And we'll be providing you the session recording for all the classes, and that will be accessible for all the students or the participants. This will be available in our website, and we'll be giving the assignments regularly. Even every 4 classes, we'll be having 1 assignment. It's a kind of quiz, and you'll be have to take up some practical laboratories as an assignment. And we also have the forum. This forum is primarily to interact with your peers and to share more knowledges. And mostly all the tech people and the RWX squad will be participating in this forum, and it will be very much helpful for you to clear your doubts and in all kind of technology, not only Docker. And we'll be also providing the lab questions to practice. This will be good for all the students to practice questions we provide. That will be mostly the real-time situations and the case studies we'll be sharing you to practice on your own. And also we provide the close completion certificate, of course. And we also give you the question banks from the past interview. Some of our students and the experts in the technical interview panel derived some questions and answers. This will be very helpful for any participant to attend and clear the interviews. And of course, we'll be assist you on build your technical resumes. Okay. To the high level, as we discussed in the introduction session, we'll be covering both Docker and Kubernetes. And these are the two parts we are going to cover in this course. And the fees we set for the previous batch as well as this batch is 13,500 INR, and you can also avail the group discounts. You can contact us through phone or email. We'll give you some plans for getting the discounts for this course. Okay, how do you enroll to us? You can enroll for this training by credit or debit card or any PayPal account and make an online payment. Once the payment is received, you will be automatically receiving a payment receipt, and we will send further information about the class schedule via email and also by phone. And you will also be added into our WhatsApp group for the continuous communication with us for the further questions and the clarification to RWX. Yeah, I'll also send this contact and enrollment details, so the email for all the participants. Please feel free to share with your friends and family or seeking to get some top skill in the market. They can get trained with us. And thank you for your patience. I know we are beyond the schedule, and thank you for your patience and time. And meet you all soon. And thank you so much. If you have any questions about the course, you can do a WhatsApp message, also email. If you have any questions, you can ask us now as well. Yeah. Okay, 3, 2, 1. No questions. Okay. Keep in touch. Thank you for joining once again, and keep in touch. We'll be sending the details and the recording of the session to you through email. Thank you again. Thank you. Bye. Thank you for joining.